Hello everyone, this is the video lecture for Calculus 2, section 7.6, Integration Tables. I'm going to ask before I even get started, did you look at the amount of time that's on this video? Go ahead and look. I don't know how long it's going to be, I'm still recording it, but it's pretty short. I even have my notes here, this will be fast. 76016, we have integral from 0 to 3 pi of x cubed sine of x dx. Figure it out. Okay, well, let me just tell you ahead of time that this is a formula. That's what this integration table stuff is. I've been mentioning this a lot where I'm saying, hey, there's like 100 formulas and all that. This is exactly it. There's a section devoted to just these guys. What I'm going to do is list out the numbers, at least of the ones like in the formula book, I believe. It might be different than the ones that you see on your book or whatever. I don't know. There's a lot of different lists out there with all different numbers. This is not some kind of standard. So I'll put a number here next to it, and then I will give you the formula, and we'll talk about it. So this is technically my 84, whichever that is u to the n sine of u du is equal to negative u to the n cosine of u plus n times the integral of u to the n minus 1 cosine of u du. Now, let me make this a little bit more clear over here, u du. Now, what? Well, I'm basically saying, like, look here, they're the same. So then I could basically just copy this down. But where did this come from? How did they get this formula? Any ideas? Dun, 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 dun. Yep, integration by parts. So I'm just copying it. 3x to the 2 cosine of x dx. Okay, awesome. Now, well, how do we do this problem right here? Oh, I don't know. Maybe it's number 85, which is going to be an integral of u to the n cosine of u du is equal to u to the n sine of u minus n times integral of u to the n minus 1 sine of u du. I should just, it'd be easier if I just actually did integration by parts. But I'm trying to show that the formulas are there for you as well. That's kind of my point here. So 3 times all the stuff here. So that's going to be x squared sine of x minus 2 integral x to the 1 sine of x dx. And now I'm like, okay, well, how do I do this one? And I look around, and guess what? It's number 82, which is u sine of u du is equal to sine of u minus u cosine of u d plus c. Okay, great. So I'm just going to now substitute that in. This is all integration by parts. I mean, the entire section is basically just questions that you could use formulas on. You don't have to. I still recommend using the formulas because they're saying use the formulas, so I guess I'll just use the formulas since they say so. Plus c, right? Oh, no, there's no plus c because this is a definite integral from 0 to 3 pi, correct? Flip the page. Cool. I guess I could like distribute this stuff in and whatever. So plugging in a 3 pi into all these guys, I yield something. And then I'm plugging in 0, I'm going to get something else. Notice I also have to plug that 3 pi in right there. And right here. And way over here. So there's a lot going on. So here's my very silly answer. Negative 3 pi cubed. Cosine of 3 pi plus 3 times 3 pi squared sine of 3 pi minus 2 times sine of 3 pi minus 3 pi cosine of 3 pi close, close, close. Yep. Minus sign. All this minus a negative will make a positive. And I'm going to plug in a 0, 0 cubed. Cosine of 0 plus 3 times 0 squared. Sine of 0 minus 2 times sine of 0 minus 0 times cosine of 0. Close, close, close. Okay, well, 0 here cancels, 0 here cancels, that cancels, 0 here cancels, everything cancels, so you don't have to worry about that guy. Up here, if you type this into WebAssign directly, it should work. But just to try to make it a little better, you know what I mean? Sine of 3 pi is going to be a 0, so this whole thing goes away. This guy goes away. I'm going to get a -1 out of that, so 2 negatives make a positive. 3 pi cubed plus 3 times, and notice that this 2 and the 3 actually combine, so I should just say -6 times. Way over here, again, that's going to be a -1, and so then I got another negative with this negative. So it's 2 more negatives with this one. Should still make it a negative in the end. 3 pi times 1, I guess. And so my answer, I guess, is 27 pi cubed minus 18 pi. Yes, that's what I got on my notes. And there we go. Just type that thing in if you want to. All right, 76017. Integral of e to the 2x divided by 13 minus e to the 4x dx. What I need to do here is make a u substitution, and then I'll be using the integration tables. My derivative will be a 2 coming down to the front. And I'm going to go ahead and go the full way here so that I get my du divided by e to the 2. There's a 2 still down there. Okay, so these guys I'm going to kind of like plug in, I guess you can say. So I got e to the 2x. I got 13e, minus e to the 2x squared dx. Now do you see it? But what I want to do is I only want to plug in my u there. I know that you're tempted to plug in a u right here, but that's actually going to cancel here in just a second with my du business. Like that. And so my 1/2 can come to the front. Integral of 1 over 13 minus u squared. I'm feeling that arc tangent. That's not an arc tangent, it's something else. But I just have that feeling all the time, don't I? Don't believe me. So there's this format, this style, and I'm looking around my integration tables and stuff, and it's number 19, which is going to be du. I got a squared minus u squared is equal to 1 over 2a ln of the absolute value of u plus a divided by u minus a, and then plus c. So that's my formula. The reason why I chose it is because I have a minus and then a square. See? So this actually right here is the square root of 13 squared. So just keep that in mind as my a. All the rest I'd literally just plug in. So 1/2 stays in the front, and then I have a 1 over 2 times the square root of 13 ln of u minus, or sorry, plus the square root of 13, and then u minus the square root of 13. What was my u originally? Was e to the 2x. These guys can combine to make the 4. Apparently in my notes somewhere I missed that 1/2. Yep, I just completely didn't see it. Okay, well, I want to fix my notes on that one. That 1/2 is still in the front, and so then I should have 1/2 here, making a 4 in the end. I should have changed my notes on the last one. If you remember, I had a weird thing there too. It happens. It happens. So e to the 2x plus the square root of 13, e to the 2x minus the square root of 13, and then plus c. There's no definite integral. We're done. That's it. Yeah, we're done. We're done with this entire section. That was it. And so to make it as quick as possible, I'm going to say thank you very much and have a great day.